Alright, let's talk scatter plots. Now, scatter plots are very simple. There's only a few things you need to know about them. So let's start with different types of scatter plots. So as you can see, I'm drawing my L shapes for my graph, my first quadrant. And now I'm putting a bunch of points. And a bunch of points. Oops, that one's not a point. That's a whole line segment. And points. What I want you to notice is there is a trend to my points on each of these graphs. This first graph, this is what we would call a positive correlation. This means that as one variable increases, so as my x increases, my y increases. So you can see as my x increases, so that means I'm going this way on my x-axis and this way on my y-axis. Those points are higher than when I'm down closer to the origin. For this next graph, I have a negative correlation. That means that as x decreases, y increases, or I could have it where x increases, y decreases. So negative correlation just implies that the opposite thing is happening between my two variables. So my scatter plot will move in a downward right fashion. This last one is no correlation at all. That means those dots are kind of just doing them. They're not worried about anybody else. They are just there, kind of scattered about. There's no trend in those dots. Okay, so those are the three main types of correlation, and then we can discuss how to tell if it's a strong or a weak correlation next. Alright, not right now, but one day in the future, we will learn about the correlation coefficient. So correlation coefficients always measure between -1 and 1, okay? And technically, those are not arrows on the end because that is literally the only range for your correlation coefficient. Logically speaking, if your correlation coefficient falls over here, you should know that it is negative. Just like on a number line, to the left of 0 is negative, therefore to the right of 0 will be positive. Hopefully that is not new material for you. Now, to determine the strength of your correlation, the closer your number is this way, the stronger it is negatively. As such, the closer it is this way, the stronger it is positively. If it falls close to 0, it is weak. So visually speaking, if we're talking strong versus weak, strong correlations are more clustered or more grouped together. So they're either clustered in a positive way or clustered in a negative way. It does not matter. Positive or negative correlations can both have a cluster. If they are weak, that is when those dots are all over the place. Hashtag doing me. Not worried about any other points. Just doing me.